All right, welcome back. Today we're looking at 1-13, log, to and from exponential. So when we start getting into exponential and logs, know that they undo each other. They're like inverse functions. So an exponential will undo a log and a log will undo an exponential. We'll get into that more later. But in order for us to understand it well, we have to talk about the parts of exponential and how they fit into the log. So if we have an exponential statement like we have here in equation, 4 to the third we know is 64 because 4 times 4 is 16 times another 4 is 64. Our 4 is our base, our 3 would be our exponent, and then the 64 is the value we get when we take the base and the exponent and apply them. All right, in logarithmic form it has the same values in there, so this is the equivalent logarithmic function to the exponential function. It's like saying I can write 2 times 3 equals 6, right? But I can also write it as a division, like 6 divided by 2 equals 3, right? So multiplication and division are related in the same sort of way that exponentials and logarithmics are related. So in a logarithmic form, we have log base 4, so that's our base. 64 is our value, and 3 is our exponent. All right, so the key to logs is when they tell you the log base of the value, what your answer is going to be your exponent. So it's asking us 4 to the what power is going to give us 64, so we know that's 3. Okay, one more thing to note is that you're going to see ln pop up here. And I did some research back in the day because I didn't understand why natural log was ln and not nl. And the reason is because it's from, I think I want to say it's French, some European thing. It's logarithm natural. So that's why we do ln. And all that means is that our base is going to be e. And we kind of talked about e earlier when we did our continuously compounding interest, right? So e is approximately 2.71. It's like pi. It doesn't repeat or terminate. So it's just saying that the base for these natural logs we assume to be e. All right, so let's look at some examples here as just kind of getting your feet wet, getting you comfortable. So it's asking us rewrite as a log. So remember, when we do our logs, it's going to be log, our base. So we have to identify our base here. So log base 4. Our value is 1/16. And that's going to be equal to our exponent, which is -2. Okay, so just again, base, value, and it's always going to be equal to the exponent. Okay, let's do that in reverse. So rewrite as an exponential. This is our base. This is our value. This is our exponent. So then we're going to write our base first. We're going to put our exponent on it, and it's going to be equal to the value. And then we can check, right? 3 to the 4th is 81. 3 times 3, 9 times 3, 27 times 1 more 3 is 81. So we know we did it correctly. Okay, for these ones, we're just going to rewrite them. So this one's in log form, right? Because it's ln. So what we know about log form, if we're writing it as an exponential, ln again means base e. Right, so we're going to put e as our base. Our exponent is 7. And then our value is x. So once you get the hang of these, it's pretty easy. So number 4, notice we have a base e. So rather than log base e, we're going to say ln. So let's write this as a log. So ln of our value is going to be equal to, always remember, right, is going to be equal to our exponent. Exponent base, which told us to do ln value is equal to exponent. Okay, when it's asking us to evaluate, all it's doing is telling us to simplify, give me an answer. So in these cases, it's easier to rewrite it as an exponential. So again, our base is 5. We're not sure what our exponent is, so we're going to put an x in there, and then our value is 25. So 5 to the what power is 25? Well, then x has got to be equal to 2, because 5 squared is going to give us 25. All right, likewise for b, our base is 2. We're not sure what the exponent is, so we'll put an x in there. And then our 32 is our value. So 2 to the what power is 32? So let's count it. 2 to the first is 2. Squared is 4. To the third is 8. To the fourth is 16. To the fifth is 32. So x has got to be equal to 5. And then the last one, it's asking us to solve for x. So let's again rewrite this as an exponential. So 27 to the 1/3 power is equal to x. Now, I'm not sure if we covered this before, but anytime we have a fraction as our exponent, the top is our power, the bottom is our root. So 27 to the first power is 27. That's not changing. But what we're trying to do is find the cube root or third root of 27. So what times itself is 27. That's going to be 3. Okay, so that's it for today. Make sure you have your notes taken down. If you have any questions, please also write those down. We can go over them next class. Good job today.